Okay, we're going to pick up right where we left off in the chapter 1 test review yesterday. We left off with the segment addition situation. So now we'll look at distance and midpoints and then our angle relationships. So the first thing we want to talk about is the distance between 2 points. If you remember, we used Pythagorean theorem for this. We have to do two things. We have to look at the distance between each one of these gives us an x and a y. So we want to find that straight linear distance between the two x coordinates first. So my x coordinates here are 1 and 4. So the distance from 1 to 4 is just 3. We don't need a positive or negative sign. You'll see I won't really even write out any subtraction. I'll just think about how far that is. And then the distance from 3 to 6 is also 3. So using Pythagorean theorem, I take those two distances, I square them, and I take the square root of this. So this would be 9 plus 9, and we will square root that. And we can just leave it as the square root of 18. If you want to be fancy and you know how to simplify that, it's 3 root 2. But square root of 18 is going to be just fine, especially for our situation on the test. Okay. So next one here, we have the distance between 8, or number 8, the distance between -2, -1, and 8, 3. Okay. So let's answer that in the Edpuzzle. So hopefully we were able to do a couple of things here. First and foremost, think about how far it is between -2 and 8. That's going to be 10, and we have to square that. Then how far is it from -1 to +3? That's 4. Okay, going from negatives to positives, it's a longer distance. So we should have had 10 squared plus 4 squared, and we take the square root of that. It's going to be 100 plus 16. And don't forget the radical, and we can just leave that as the square root of 116. Okay, so moving on, now we have midpoints, a little bit different. In my opinion, probably even easier. For midpoint, we just take the two coordinates, we take our two x coordinates and we add them together and divide by 2. So I'm going to take -9 plus 5, add that together, and then I'll divide that by 2. Then I'm going to look at my y coordinates, 3 and 7. I'm going to add those two together and divide by 2 as well. And that's it. That's my midpoint. So -9 plus 5 is -4. We'll divide that by 2. We have 10 divided by 2. So this would be -2 and 5. So if I were to plot the original 2 points and then plot this point, I would see that this point here lives right in the middle of those original 2 points on our coordinate plane. Okay? Let's try number 10 and put the answer in the Edpuzzle. So hopefully for this one here, we took -12 plus -8, add them together, and divide by 2. Then we're going to take -7 and -4, add those two together, and divide by 2 as well. Okay, so I'm going to have -20, and we'll divide that by 2, and then this would be -11, just a lot of negatives here. So I get -10 and -5.5 as my correct midpoint. Again, so think if we plotted these on graph paper and then we plotted this point, we'd see that this point lives right in the middle of those 2 points. Just add them together, divide by 2. That's midpoint. Okay, for distance, you're going to use Pythagorean theorem. Okay, and then finally, the last thing we talked about in this chapter were angle measures and then polygons. So name angle 5 in a different way. So where's angle 5? He's right here, right? What's another way to name angle 5? It's this angle right here. Okay, how else could we name that angle? So hopefully we said that that would be angle STW. Okay, another way to name angle 5. Let's try the same thing for angle 2. What's another way to name angle 2? He lives right here. Right, how else could we name angle 2? Let's answer that in the Edpuzzle. So hopefully we said angle T to V to W. Okay, vertex of angle 3, that's just a point. Okay, what is the point at which angle 3 lives? How would we name that point where angle 3 lives? He's right here. What point lives in the vertex of that? He would be the middle letter if we were going to name angle 3. So hopefully you answered point T for that. Okay. Now sides of angles, keep in mind sides of angles are rays. So the sides of angle 4 would be first we have this ray here that goes out from T to S, and then we have this ray here that goes out from T to U. So how would we name those two sides? So we have ray TS, that's the first side that I drew in there, and we also have ray TU. So notice I have to be careful about where I put that, and notice the vertex T starts both of those off. Okay, so let's do the same thing for angle 1. What are the sides of angle 1? Angle 1 lives here, so here's one side to angle 1, goes out that way, and then the other ray that's a side of angle 1 goes out that way. What are those two rays? So hopefully we said we have ray WT. It didn't come out right. So that's ray WT, and we also had ray WV. Those are the two sides of that angle. And then finally we'll have some algebra here. In the first figure we have an angle bisector, and they tell us that angle ABD is 4x plus 5. So we'll put our 4x plus 5 in there. And then D to B to C is 2x plus 9. So two things I have to do here. I have to find x, and then I have to find ABD. Well, I already know what ABD is. It's 4x plus 5. But if in order to find out the value of that, I have to find x. So what's the equation to solve for x here? Okay, so hopefully we said that our equation to solve for x was 4x plus 5 equals 2x plus 9. Okay, so next step, let's go ahead and solve that. Tell me what you get for x. So a couple steps here. We would subtract 2x from both sides. So now all the x's live on the left-hand side. So I have 2x plus 5 equals 9. And I'm going to subtract 5 from both sides. So here we have 2x is equal to 4. And then just divide by 2. X would equal 2. So x is 2, but now let's finish the problem. If x is 2 and ABD is 4x plus 5, what is the measure of angle ABD? Last part. So hopefully we came up with 4 times 2 plus 5, right? ABD is 4x plus 5, so this is going to be 8 plus 5, or 13. So we know that two answers here. X was 2, and then ABD was 13. And we'll do some more algebra solve here. So here we have two vertical angles, so hopefully we know the right equation for that. What's the relationship between 5x minus 2 and 4x plus 17? So vertical angles are equal. So we want to go 5x minus 2 equals 4x plus 17. And the directions were to solve for x, so tell me what you get for x there. Solves pretty quickly here. We subtract 4x from both sides. All right, so I have 1x right away, minus 2 equals 17. So we'll just add 2 to both sides. So I have x equals 19. That's all we had to do there was solve for x, okay? Number 2, what's our equation to solve for x here? Okay, so hopefully we said that these two angles form a linear pair. They're adjacent and supplementary. So what we'll need to do here is add them together and set that equal to 180. Okay, so go ahead and solve for x now the rest of the way here. Okay, so notice we have all the x's on one side, so I can combine like terms first. So I have 9x, right, and then I have to do 45, which is positive 27. 45 minus the 18 would give me positive 27, and I set that equal to 180. It looks like I have all multipliers of 9, so this should work out evenly for us. So 9x is equal to 180 minus 27. I think that's going to be 153. Okay. And then we divide both sides by 9. 153 divided by 9. You can use your calculator for that. And we should get 17 again. Oh, I got 19 last time. Sorry. X equals 17. Okay. Last one, solve for x. What kind of angle situation do we have here? Set up that equation. So hopefully we said that x plus 25 plus x, they're complementary, is going to add to 90. So combine your x's. We have 2x plus 25 equals 90. Subtract 25 from both sides, and I'll get a decimal here. 2x is going to be equal to 65, so I'll divide both sides by 2. So x here should be 32.5. And the very last thing to review is what we looked at with polygons. We'll try to keep this as simple as possible. But we want to talk about the number of sides that a polygon has. So in the first one here, we have 1, 2, 3, 4, 5, 6. So what do we call a figure with 6 sides? And so hopefully we said that that was a hexagon. Oops. Right. And now we want to look at the polygon and decide whether it's convex or concave. So number 1, is that convex or concave? And we should say that that's definitely concave. It is caving in. It's not convex. And now the last part of this, is it regular or irregular? And this would certainly be irregular because all 3 sides are not equal there. Okay. So the next one, let's try to do all 3 at once here. Number 2, let's classify the number of sides: convex, concave, regular, irregular. So counting the sides is a little tough. This is pretty small here, but it's a nonagon. It's kind of cramped in there. 9-sided figure is a nonagon. It's definitely convex. It's not caved in any way. It looks nice and pretty. But it is regular. All the angles are equal and all of the sides are equal, so that's what classifies it as a regular polygon. Okay, and the last one, let's do all 3 at once. So hopefully we recognized right away this has 4 sides. It's a quadrilateral. Okay, it is convex. It's not caved in. And it is irregular. It only has 2 sides that are equal and doesn't look like any of the angles are equal either. Okay, so it's going to be irregular. Okay, so perimeter or circumference. So for a circle, we talk about circumference. For rectangles and other shapes, we talk about perimeter, and then area. So let's do that for number 4. What's the perimeter and the area? We'll do both at once. Okay, so for perimeter, hopefully we said here that we're going to add up all 4 sides. We'll notice that we have another 17 and another 4. Okay, so 17 times 2 is 34. So I'd have 34 plus 8. 4 and 4 is 8. So I have 34 plus 8 is 42 feet for the perimeter. And then for the area, we are just going to multiply 17 times 4. And I get 68 for that. And that's going to be square feet. Okay. So for the circle, we can leave our answers in terms of pi, not get a decimal. Okay, so same thing. What's the circumference and the area? So we want circumference. And we would like area as well. Both of those. So if you recall, for circumference, it's 2 pi times the radius. That's how we execute the circumference. 2 pi times the radius. So in this case, that would be 2 pi times 7, and 2 times 7 is 14 pi miles. Okay, and then the area is pi times the radius squared. So that's going to be pi times 7 squared, which is 49 pi. And again, this is going to be square miles. Okay. And the last one, number 6. We want to get the perimeter and the area. So for perimeter, we had to acknowledge here that there's another 8.1 here. Hopefully we didn't miss that. So I would need 8.1 plus 8.1 plus another 8. And we add those up and should get 24.2 millimeters. And for area, for a triangle, it's 1/2 the base times the height. So 1/2 base times height here is going to be 1/2 times 8 times 7. So 1/2 times 8 is 4, times 7 would be 28. And it's 28 millimeters squared.